Thank you for joining. We will begin in a few minutes. Please note that while we've tried to maximize platform access, the Zoom experience may vary based on your device, version of Zoom, or internet bandwidth. Thank you. Thank you for joining. We will begin in a few minutes. Please note that while we've tried to maximize platform access, the Zoom experience may vary based on your device, version of Zoom, or internet bandwidth. Thank you. Thank you for joining. We will begin in a few minutes. Please note that while we've tried to maximize platform access, the Zoom experience may vary based on your device, version of Zoom, or internet bandwidth. Thank you. Thank you for joining. We will begin in a few minutes. Please note that while we've tried to maximize platform access, the Zoom experience may vary based on your device, version of Zoom, or internet bandwidth. Thank you. Thank you for joining. We will begin in a few minutes. Please note that while we've tried to maximize platform access, the Zoom experience may vary based on your device, version of Zoom, or internet bandwidth. Thank you. Thank you for joining. We will begin in a few minutes. Please note that while we've tried to maximize platform access, the Zoom experience may vary based on your device, version of Zoom, or internet bandwidth. Thank you. Welcome to the San Antonio International Airport Noise Exposure Map Public workshop. All participants are automatically muted upon arrival and will remain so through the entire meeting. And those who are attending using Zoom can only see our panelists. This workshop will be recorded, and the recording, as well as the other materials, will be made available on the airport's Noise Office website. If you're attending using Zoom and having trouble viewing or hearing, please use the Q&A feature found at the bottom of your Zoom screen, and someone on our technical support team will assist you. Or you can text 205-697-3432. Again, the number to text for assistance is 205-697-3432. Today's workshop is expected to run about 2 hours and includes a 20-minute pre-recorded presentation. At the conclusion of the recorded presentation, we will answer your questions in the order they are received. To submit a question, please use the Q&A icon found at the bottom of your screen. Please note, these will not be considered official public comments. Please follow the instructions shown on the screen and also provided on the airport's Noise Office website and in the newspaper advertisement to submit your comments on the NEM update. For those of you who have called into this workshop but are not in the Zoom interface, you can text your questions to 205-697-3432. Again, 205-697-3432. As we begin this meeting, the Honorable Councilman Perry from District 10 and the Honorable Councilman Courage from District 9 have recorded welcoming messages for you.
Howdy. I want to take a moment of time to thank everybody for coming out tonight and participate in this workshop, especially those from District 10. Wanted to also thank the airport staff, Jesus, Steve, and Josh, for organizing these workshops to give us an opportunity to take a look at this process and what our current maps are looking like and what these future maps will be looking like also. These workshops will continue through next week, and it'll provide an opportunity for all of us to learn more about that process and how the maps will be presented tonight and how they were developed and how the future conditions map will look like also. Look forward to tonight and appreciate the opportunity to review these future conditions map and provide comments. Thank you all and be safe.
Hello, this is District 9 City Councilman John Courage. You're here to receive information from the San Antonio Airport Management Team about the work they're doing to assess noise problems that continue to plague people around District 9 and around the airport. Your participation is very important. A lot of this information will be shared eventually with the FAA, and steps will be taken, hopefully, to mitigate the noise problems that concern many people who live in and around the San Antonio airport. I hope your full participation will add a lot to the work they're doing to help improve the quality of life for all of us who live in and around San Antonio airport. Thank you.
I will now turn this over to the Director of the San Antonio International Airport, Mr. Jesus Saenz, who will provide some brief opening remarks before we share the pre-recorded presentation.
Welcome to the San Antonio International Airport Virtual Public Workshop for our Part 115 Noise Exposure Map, or NEM, update. I am Jesus Saenz, Director of Airports for San Antonio Airport System. I'm here to thank you for joining us once again for our virtual workshop and to give you some history of the noise exposure map in an effort to put everything into context. The City of San Antonio completed its first comprehensive Part 150 study in 1990 and has conducted numerous updates throughout the last 30 years. These updates ultimately resulted in the Comprehensive Noise Abatement and Mitigation Program. This noise exposure map update allows us to better understand the current noise exposure environment as well as the current concerns of our nearby communities. This is the second and the final series of workshops that will occur during the 2021 NEM update process. The first set of workshops, held back in October 2020, reviewed the assumptions and resulting contours associated with the development of the FAA 2021 Existing Conditions Noise Exposure Map Draft. This second set of workshops focuses on the draft for the 2026 Future Conditions Noise Exposure Map. We have historically conducted our public workshops in person, but in an effort to remain compliant with current COVID-19 guidelines and encourage maximum participation while maintaining the safety of everyone in our community, we're continuing the use of a virtual platform. I know a virtual approach may not feel as personal to some, but I am optimistic that we can still have an engaging discussion around the noise exposure map update, just like we did in October of last year. Thanks again for joining us, and we look forward to hearing your questions and your concerns. That is why we are here.
Thank you, Mr. Sines. We will now begin the public workshop presentation.
Hello, and welcome to the virtual public workshops for the San Antonio International Airport's Part 150 Noise Exposure Map Update. I'm Steve Alberson, the Environmental Science Associates Project Director for this study. We appreciate you attending this workshop today. Your participation and input is a key component of this study. This set of workshops is a continuation of the workshops we held in October 2020, where we presented the draft 2021 Existing Conditions Noise Exposure Map. Today, we will review what was covered in that first set of workshops, including information about the 14 CFR Part 150 study process, how sound is measured, how we model aircraft noise, and what is considered compatible land use. However, we will also discuss the draft 2026 Future Conditions Noise Exposure Map. 14 CFR Part 150 refers to Title 14 of the Code of Federal Regulations, Part 150, which outlines a voluntary process that an airport sponsor can undertake to identify and address non-compatible land uses in the vicinity of an airport. Noise studies, including a noise exposure map update, must comply with 14 CFR Part 150 guidelines in order to be accepted by the Federal Aviation Administration, or FAA. Part 150 establishes a methodology to prepare aircraft noise exposure maps, or NEMs, and noise compatibility programs, or NCPs, when applicable. If noise exposure maps show that there are non-compatible land uses and a noise compatibility program can then be undertaken, it's important to note that the process also provides airport sponsors with an opportunity to engage local stakeholders, including you, to hear their concerns. The proactive engagement process of Part 150 is an excellent way to educate the community about the existing noise environment and identify areas of non-compatible noise exposure and their potential eligibility for noise mitigation. While it was too early in the process to determine future potential eligibility during our first set of workshops in October 2020, today we'll be presenting the draft 2026 Future Condition Noise Contours and the associated impact analysis, which will help inform future discussions regarding potential eligibility for acoustical treatment. Aircraft noise is regulated at the federal level. The FAA is the responsible federal agency and will ultimately accept the noise exposure maps once they are found in compliance with the requirements of 14 CFR Part 150. The FAA approves the flight procedures and certifies pilots and aircraft, both of which influence noise in your area. State law establishes the zoning and land use compatibility framework. Although local governments can establish noise ordinances, aircraft operations are exempt from those ordinances. As such, as the airport owner and operator, the City of San Antonio has very limited authority in adopting noise restrictions. The city is primarily responsible for building and managing airport infrastructure such as terminals and runways to meet the needs of the traveling public. Local jurisdictions and states can promote compatible land use through methods such as zoning, establishing real estate disclosure requirements, and mandating sound insulating building materials. 14 CFR Part 150 requires documentation of the noise exposure in the vicinity of the airport, specifically the day-night average sound level, or DNL, 65, 70, and 75 contours. A noise contour depicts the levels of equal aircraft noise exposure. The noise exposure map reflects the DNL contours presented over land use base maps. Base maps depict an airport's layout, local land use jurisdictions, major land use categories, noise-sensitive receptors, and other information required by 14 CFR Part 150. All land uses outside the DNL 65 contour are deemed by the FAA to be compatible with aircraft noise. 14 CFR Part 150 requires NEMs for the year of submittal to the FAA and a 5-year forecast. Therefore, this study will develop noise contours for the 2021 existing conditions, or baseline year, and the 2026 future conditions year. For this Part 150 study, 2019 airport operations were used to represent the 2021 baseline operations. In consultation with the FAA, it was assumed that no growth in aircraft operations would occur between 2019 and 2021, given the global slowdown in aviation activity due to the COVID-19 pandemic. Similarly, and in consultation with the FAA, a 2-year delay in the operational growth was assumed for the 2026 future conditions. As such, the 2024 activity forecast was used to represent the 2026 operating conditions. This is an overview of the NEM update process. Up to our current point for the first set of public workshops, we have identified key issues, gathered and analyzed airport and aircraft operational data, developed land use maps, and generated draft noise exposure contours for the 2021 existing conditions and 2026 future condition years using the FAA-approved Aviation Environmental Design Tool, or AEDT. Our most recent step was to analyze the population and land uses associated with these noise contours and document the findings in the NEM update report, which is available for review at the airport's Noise Office website. After stakeholder comments on the draft NEM report are reviewed and addressed, the final NEM update report will be sent to the FAA for acceptance. The FAA has adopted the day-night average sound level, or DNL, as the primary metric for 14 CFR Part 150 studies. DNL represents the total cumulative sound exposure in decibels over a 24-hour period. This metric considers the total number of operations at an airport over the course of a day. For Part 150, we are required to evaluate the average annual day. To reflect the increased sensitivity to noise at night, DNL uses a 10 decibel weighting for nighttime events between 10 p.m. and 7 a.m. Because noise is measured on a logarithmic scale, this essentially weights each nighttime event as equivalent to 10 daytime events. Average annual day aircraft noise exposure is calculated over a broad area and depicted using contour lines of equal noise exposure. The left side of this slide shows the building blocks of DNL, which involve generating hourly average noise levels and ultimately a 24-hour average sound level plus the addition of nighttime weighting penalty between 10 p.m. and 7 a.m. This slide shows the various activity levels that can combine to result in the same amount of noise exposure. While two people may experience the same noise exposure in terms of DNL, they may experience a very different number of aircraft overflights and noise levels depending on the time of day and where they are located around the airport. This study is required to use the FAA-approved Aviation Environmental Design Tool, or AEDT, version 3C. AEDT uses detailed aircraft operational information to generate noise contours. Data inputs used in the modeling process include aircraft fleet mix information, such as aircraft type, arrival and departure times, trip distance, runway use, flight track location and usage, and weather conditions such as average temperature and humidity. For this Part 150 study, we generated the draft 2021 existing condition noise contours by using actual calendar year 2019 operational data, and we generated the 2026 future condition noise contours by using the 2024 activity forecast. Noise modeling provides airport sponsors with key insights into the current and projected noise levels in the vicinity of an airport, especially how noise exposure is affected by changes in aircraft fleet mix or changes in aircraft operations and procedures. It can also provide the community with insights into noise exposure, as well as how that noise exposure is anticipated to change over time. You may be wondering why we use modeling instead of actual noise measurements. While noise measurements provide noise levels at a specific point and can be helpful when understanding historical trends, they provide limited information when evaluating DNL over a broad area surrounding an airport. Noise monitors may also include the contribution of non-aviation noise sources. As a result, FAA and Part 150 regulations require the use of a computer model to determine noise exposure. This allows calculation of noise exposure at numerous points around the airport, and it also enables the prediction of future noise exposure levels based on expected changes in aircraft activity. Regulatory guidelines for noise and land use compatibility are included in Table 1 of Appendix A of 14 CFR Part 150. The FAA has established DNL 65 as the significance threshold for noise-sensitive land uses such as residential, places of worship, and schools. All land use types located outside of the DNL 65 contour are considered compatible for the purposes of 14 CFR Part 150. Noise-sensitive land uses include residential, places of worship, schools, libraries, hospitals, and more. To accurately capture all the various noise-sensitive land uses, we consulted more than a half dozen publicly accessible data sources to gather the information. All noise-sensitive sites within the DNL 65 contour are depicted in the land use maps and are identified in the Noise Exposure Map Update Report. San Antonio International Airport conducted its first Part 150 study in 1991, which signaled the beginning of the noise program and office. Since then, the airport has been extremely dedicated to understanding current noise conditions through multiple updates to noise exposure maps and working with the community to reduce their exposure to aircraft noise through multiple updates to their noise compatibility program. The airport currently has a comprehensive and proactive noise management program with a very high compliance rate for noise abatement measures. The airport's noise outreach program is also quite extensive, and to maximize transparency, it has invested in systems that allow daily and monthly reporting, an online noise complaint portal, and more. San Antonio's noise program and best practices are often referenced by airports seeking to further enhance their noise programs. Last year, the airport wrapped up its Residential Acoustic Treatment Program, or RATP. The RATP was a huge success for both the airport and the community. With the help of millions of dollars from the FAA, more than 3,300 housing units received acoustical treatment. The airport's Noise and Operations Monitoring System, or NEMS, was installed in 2017 and is extremely useful in capturing aircraft operations data, determining noise levels during aircraft overflights, and tracking noise complaints from the community. The community has access to all this information via a portal on the airport's Noise Office website. The airport currently operates 12 noise monitoring terminals, or NMTs, that are generally located within a few miles of the airport along the arrival and departure paths for each runway. While these NMTs can capture certain data related to aircraft overflights, it's important to note that the sound levels they record are not used to generate the noise contours we will present here today. NMTs measure sound at a single location and therefore cannot be used to determine cumulative noise exposure over a large area. Part 150 requires us to use the 2021 forecasted operations number in the AEDT noise model to determine the 2021 existing conditions NEM. Because the COVID-19 pandemic has seriously disrupted global aviation activity, predicting future aircraft operations is filled with uncertainty. Rather than trying to capture and model that uncertainty, in consultation with the FAA, we use the last reliable full year of aircraft operating data, which was calendar year 2019. Similarly, Part 150 requires us to use 2026 forecasted aircraft operations in the AEDT noise model to determine the 2026 future conditions NEM. In consultation with the FAA, we assumed a 2-year delay in future aircraft operations growth due to the COVID-19 pandemic. Therefore, the 2024 pre-pandemic forecast was used to depict the 2026 aircraft operations. Both the 2021 and 2026 annual aircraft operations are shown here. The number of aircraft operations is the biggest factor for determining the size and shape of the noise contours. As we previously discussed, aircraft operating at night receive a 10 decibel penalty, so the time of day can also have a noticeable effect on the DNL contours. Please note that the data and references used to populate the tables in this presentation can be found in the Draft Noise Exposure Map Update Report, which is available for download at the airport's Noise Office website. Aircraft departure stage length is also an important factor affecting the size and shape of the noise contours. Stage length is the distance an aircraft flies from the airport to another airport. Shorter flights typically involve smaller and lighter aircraft and usually carry less fuel. As such, their departures are quicker and steeper, which means people on the ground are exposed to less noise for shorter periods of time. Generally, the larger the plane and the longer the stage length, the more noise exposure to people on the ground. Runway utilization is another important factor affecting the size and shape of the noise contours. Higher runway utilization generally results in larger noise contours. Importantly, the airport cannot control runway utilization. It is determined by the FAA Air Traffic Control Tower, construction on the airfield, prevailing winds and weather conditions, operations at adjacent airports, and pilot preferences. Here we see current daytime runway utilization. It is interesting to note that runway 13 right will likely remain the overwhelming favorite for daytime arrivals in the future, and runway 4 will likely continue to be the most used runway for daytime departures in the future. Future nighttime runway utilization is expected to see the same proportional usage patterns, but interestingly, arrivals on runway 13 right and departures off runway 4 are predicted to be even higher at night. The next 4 slides depict the actual flight tracks or paths of aircraft departing and arriving at the airport. Flight track data was taken from the airport's NEMs and entered into ADT noise model to generate the noise contours. Arrivals are depicted by red lines, departures are depicted by blue lines. Touch and go operations, where aircraft take off and immediately circle to land for training purposes, are depicted by green lines. The thicker lines represent the higher concentration of aircraft operations, and the thinner lines represent lesser concentrated flight paths that disperse from the main tracks. We are not expecting any noticeable changes in the future aircraft arrival departure patterns. As such, the 2026 flight tracks closely resemble the 2021 flight tracks. On this slide, you see the flight tracks for aircraft operating on runway 4. These are the expected flight tracks for aircraft operating on runway 22. Here are the expected flight tracks for aircraft operating on runways 13 left and 13 right. And finally, on this slide, you see the expected flight tracks for aircraft operating on runways 31 left and 31 right. This is the draft 2021 existing conditions noise exposure map. The DNL 65, 70, and 75 contours have been placed on the existing land use map, which essentially means that this map depicts aircraft noise exposure over all land uses in the vicinity of the airport. The noise contours are represented by the solid lines. These contours represent equal levels of noise exposure surrounding the airport and are generated by an extensive noise modeling process. Because the details of this draft NEM are difficult to see in this virtual workshop setting, a high-resolution map is available for download at the airport's Noise Office website. The top table shows the types of land uses and their total acreages within each 2021 DNL contour interval. Land use types range from single-family residential, such as single-family homes, to recreation, such as public parks. The bottom table quantifies the types of noise-sensitive sites located within each 2021 DNL contour interval. This is the draft 2026 Future Conditions Noise Exposure Map. The DNL 65, 70, and 75 contours have been placed on the future or planned land use map, which essentially means that this map depicts aircraft noise exposure over all expected land uses in the vicinity of the airport. A high-resolution map is also available for download at the airport's Noise Office website. The top table shows the types of land uses and their expected total acreages within each 2026 DNL contour interval. The bottom table quantifies the types of noise-sensitive sites expected to be located within each 2026 DNL contour interval. As you can see in this comparison of the 2021 and 2026 DNL contours, their respective footprints are very similar. You will notice, however, that we are expecting to see slight increases in size to the DNL 65 noise contours to the northwest and southeast of the airport. The noise contour size increase in the northwest reflects the expected increase in aircraft arriving on runways 13 left and 13 right, and the slight increase to the southeast reflects the expected increase in aircraft departing runways 13 left and 13 right. The top table shows the anticipated increase in noise exposure between 2021 and 2026 for each land use type within their respective DNL contour interval. The bottom table shows the anticipated increases in noise exposure between 2021 and 2026 for each type of noise-sensitive site within their respective DNL contour interval. As you can see in this comparison of the 2014 and 2021 DNL 65 contours, there have been some noticeable changes in aircraft noise exposure in the past 5 years. Changes in aircraft fleet mix, an increase in aircraft operations, and changing runway use patterns have all contributed to the differences in the DNL 65 contours over time. Similar to the previous comparison of the 2014 and 2021 baseline DNL 65 contours, a comparison of the 2019 and 2026 future conditions DNL 65 contours shows that predictions of future operational activity reflect anticipated changes in fleet mix and runway use patterns. As we have previously discussed, the next step in the Part 150 study process is to address your written comments related to the information presented in the previous set of public workshops held in October 2020, this set of workshops, and the draft noise exposure map update report. Our goal is to submit the draft NEM report, which will include your comments and our responses, to the FAA by the end of April 2021. Once the FAA has had an opportunity to review the draft NEM report, we expect that by August of this year, the FAA will issue a finding that the San Antonio International Airport noise exposure maps comply with federal regulations. Questions submitted via the Q&A feature of the Zoom platform during the interactive portion of the virtual public workshops are not considered official public comments. If you would like to submit an official comment, we encourage you to send your written comments by either email or regular mail to the addresses provided on this slide. These addresses will be provided again at the end of today's workshop. We ask that you please submit your comments by 5 p.m. on Friday, March 19th, 2021. All written comments will become a part of the project record and will be included in the final NEM report. On behalf of the City of San Antonio and the entire Part 150 study team, I want to thank you for your interest and participation in the San Antonio International Airport Noise Exposure Map Update.
Thank you for joining us for the presentation. We would now like to begin the question and answer portion of today's workshop. As a reminder, please use the Q&A icon at the bottom of your screen to submit your questions. If you're unable to use Zoom to submit your questions, please text 205-697-3432. Again, that's 205-697-3432. Please note, the purpose of this workshop is to help provide information and address your questions about the NEM update. Your questions will not be considered official public comments. Please follow the instructions on the airport's noise office website and in the newspaper advertisement to submit your official comments on the NEM update. We will start by answering the questions that came through during the presentation portion of the meeting, and we'll continue by answering questions in the order that we receive them. We may group questions based on related topics, so please don't be concerned if we don't immediately answer one of your questions, but we will attempt to answer them in the order they were received. During this workshop, the Part 150 study team and airport staff will be responding to questions relevant to the NEM update process. While we value all input, we kindly request other questions not related to the NEM update be directed to airport staff outside of the workshop environment. You can email the airport at airportnoisehotline@sanantonio.gov. I would now like to introduce our panelists. I'm Autumn Ward. I'm a senior noise and environmental consultant with ESA and will be serving as the virtual platform facilitator for today's Part 150 public workshop. ESA is a consulting firm hired by the San Antonio International Airport to conduct this NEM update. And ESA has decades of experience and has completed noise studies at airports across the country. Steve Alverson is an airport noise and acoustical expert with ESA and is the project director for this study. Neil Wolf is ESA's project manager for the Part 150 study and is responsible for the day-to-day execution of the consultant team's work effort. Mike Arnold is a senior vice president with ESA and is providing oversight on the Part 150 study update process. Chris Sequeira is a noise and air quality modeling expert with ESA and provides technical insight into how the noise model operates. Tracy Beach is a senior project manager with WSP and is the deputy project manager for the Airport Strategic Development Plan or Master Plan. Joshua Heiss is the noise abatement officer for the San Antonio International Airport and is the airport's project manager for this Part 150 study. And Steve Southers may join us this evening, and he is the environmental manager for the San Antonio International Airport. Our first question, oh, there's Steve now. Our first question is for Steve Alverson. This 2026 year is not soon enough for me. I want action now, and we've been waiting since 2014 already, and you want us to wait 6 more years. I believe this is asking about sound insulation.
Thank you for passing on that question, Autumn, and welcome everyone to this evening's workshop. I guess I think of this question in 2 parts. And the first part is why is there a 2026 date? And the reason that there's a 2026 date is that the FAA requires us to prepare 2 noise exposure maps. One for the existing conditions, the year that the noise exposure maps are going to be submitted, and one 5 years in the future, which in this case, it's going to be submitted in 2021, which means that the future map will be 2026. So those are just 2 maps that represent 2 periods in time, and they're not tied to any sound insulation program. They're just information for the city of San Antonio and the FAA to consider. On the topic of sound insulation, we mentioned during the pre-recorded presentation that the airport had already concluded its residential acoustic treatment program, or RATP, which treated over 3,300 homes, and that program is now complete. One of the reasons to generate the noise exposure maps as a part of this study is to see if there would be any new homes within the noise contours that would be potentially eligible for sound insulation or acoustical treatment moving forward. And what we found by looking at both the 2021 and 2026 noise exposure maps is that there are no new homes that would be eligible for sound insulation underneath this program. So therefore, that's why there's a 2026 date. And in terms of sound insulation program, at least for the foreseeable future, based on these maps, there won't be a sound insulation program moving forward. Thank you.
Our next question is for Joshua. What is the maximum size aircraft allowed at this airport? And would larger aircraft be allowed in the future?
Well, thank you for the question. We offer 8,500 foot long runways for our commercial length runways that have a wide variety of aircraft that can utilize for both the commercial and government agencies that fly here at the airport. Typically what some of our largest airframes that are operating with right now are with the shipping companies that include MD-11s and DC-10s. Those are commonly flown here. I suppose that larger airframes could operate, but for the most part, the fleet mix includes the MD-11s and DC-10s as some of the larger ones being operated here on a regular basis.
Thank you. Our next question is also for Steve. Will you be recommending some things that we can do to our homes to decrease noise when planes fly over?
So there are typically 2 parts to Part 150 study. And the first part is the noise exposure map update, which we're describing tonight and we're responsible for completing. And then if required, if there are noise abatement measures that are needed or noise mitigation measures that are needed based on homes within the 65 DNL contour, then there could potentially be a follow-on noise compatibility program. What we've determined at this point is that there are no newly exposed homes, and therefore there's not a need to move forward with a noise compatibility program. That being said, however, one of the reasons that the airport has a noise office staff is to be a resource, to chat with them and talk about what's out there and what's available. You won't typically find the noise office staff making recommendations about sound insulation in a home because every house is different and all the treatments are different, but certainly there's a lot of information that's out there. But in terms of these reports, you won't see, or we will not be providing specific recommendations about what individuals can do inside their homes. Thank you.
Our next question is for Neil. Is there a better map that outlines the areas that aren't included in the 65 contour?
Yes, there is, and I can certainly empathize with the person who asked the question. It is difficult to be able to make out detail on your computer screen or your phone screen this evening. However, there's a couple of ways that you can see a much higher resolution map. As Steve Alverson discussed in the presentation, this presentation, along with the draft NEM update report, which has high resolution maps, is available for download at the airport's noise office website. There it is, right on your screen. It's that link down there at the bottom. I would suggest what you do if you want to download the report is go to Appendix I, and there's some really large high resolution maps of the 2026 existing contours, existing conditions, contours, and the 2026 future conditions. You can also go to a number of the public libraries in the San Antonio area and pick up a printed copy if you'd like. So there's a couple of different options there for you. And then Josh, looks like you wanted to add something.
For those libraries, you can visit the Central Library, you can visit the Thousand Oaks branch, you can visit the Tobin branch, Brook Hollow, and Westfall. And each of those locations will have copies of the presentation and the reports available upon request.
Thank you. The next question is for Chris. Will elevation be taken into account during the map update? Houses that are more elevated due to topography are subject to higher noise levels.
Thanks for relaying that question, Autumn. So I can confirm that for our modeling process as described in the presentation, we did use terrain data, and that type of terrain data is official data provided by the U.S. Geological Survey. There's the function within AEDT to input that terrain data, and as the question references, that elevation information is used to calculate the noise levels. So the contours were produced using terrain data and how elevation can affect sound levels.
Thank you. The next question is for Mike. It's hard to tell how many flights are in 2026 will be added per day or per night from what we currently experience or what was experienced in 2019. And they noted that they lived on the approach for runway 13 right, so that particular approach would be of interest.
Sure. The runway 13 right currently experiences about, on an annual average day, 153 arrivals. That would increase to 164 in the future. And that breaks down in 2019 with 124 of those being during the daytime. That would increase to 134 in the daytime in 2026, and 29 during the nighttime, which increases to 31 in the nighttime by 2026. Now, they might not add exactly due to rounding because we are, again, looking at an annual average day. I think it's off by, maybe off by one when you add those together. But that's how the runway use would change relative to those 2 years.
Thank you. The next question has two parts. The first part is for Joshua. Is the RATP program, so the Residential Acoustical Treatment Program, no longer active? We were told that our home was to be included and it ran out of funds, and now it appears we are no longer in the 65 contour.
So thank you for the question. The program is no longer active because all eligible properties were completed treatment in the spring of 2020. The program would often have updates to the contours every 5 years, and as those contours changed, eligibility changed for different properties or different residences surrounding the San Antonio airport. So early editions of the contours, when they were first run in 2004, were very large, went out great distances from the ends of the runway. And then as updates to fleet configuration and changes in aircraft design were included, contours changed over time and moved closer to the ends of the runway. And that moved people's status of being eligible to participate to non-eligible because they weren't within specific contours. There may have been other individual circumstances based on the construction of the home or the sound levels in homes as well that could have caused those conditions to make a house ineligible. Thank you.
The second part is for Steve. Why has the 65 decibel contour for runway 4 shortened so significantly, especially in comparison to the northwest-southwest runways?
And I believe Joshua covered that to a certain extent, but I'll certainly be more explicit. The contour have changed primarily due, or gotten smaller primarily due to the changes in fleet mix. Those changes are most dominant in terms of improvement in fleet mix in the areas of departures. So as aircraft have gotten quieter, since the early noise exposure maps at San Antonio International Airport were prepared, those departure driven contours have shrunk back a little bit. And so we're speaking specifically about departures on runway 4. The reduction in noise exposure of the newer fleet mix, the newer aircraft types, is not as great on arrivals. So we don't see the arrival contours changing that substantially over time. So that's why we see the arrival portions of the contours, particularly to runway 13 right, be a little bit longer and look more extended, and the departure contours being a bit foreshortened off of runway 4.
Thank you. The next question is for both Joshua and Mike. And my screen just moved, sorry. With the Affordable Housing Initiative, the areas around Blanco and West were proposed for more high-dense residential, as well as the entire Blanco corridor. Would this be a conflict with compatible land use? And is the airport doing anything to address concerns related to high-density development along the corridors?
To start answering this question, I think it may help us if we were able to take a look at one of our contour maps. Neil, if you could queue up the overall 2026 future conditions contours, that would be great. And taking a look at these maps in the Blanco corridor along here, what we take a look at and provide to the community is awareness of where noise is generated from aircraft operations with these contours, so that planners are aware of where noise is in the community, and most importantly, where it will be going into the future with our dates identifying for future conditions into 2026. We coordinate with a lot of the different city offices when proposed developments occur and reference these maps to identify where those incompatible areas will exist, and to make those developers aware of where that noise comes from in relation to the airport and what those noise levels will be. Was Mike also going to answer some information?
Sure. Josh, I was just going to add, the report does have a number of graphics that reflect changes in future land use that are occurring in and around the San Antonio area. These are transitional land uses that are changing from one type of a use to another. It may be a use that's less compatible with noise. It may be a use that's more compatible with noise. So we researched that as part of the project as well, and that's documented in a series of maps. I believe in Chapter 3, Neil, correct me if I'm wrong, but that we did look into that information, but it's correct. I mean, if we were to have increased residential densities within these areas of high noise exposure, part of this planning effort is to try to avoid those situations, so that we're planning housing and noise sensitive uses in as compatible a fashion as possible relative to that future exposure.
Thank you both. The next question is for Steve. Knowing that the noise has increased and will be increasing even more within the next few years, what will be done to compensate residents that will be impacted?
Thank you for passing on that question, Autumn. As I'd mentioned a few minutes ago, while there is an increase between the 2021 and 2026 contours, small increase in noise exposure, it's not a substantial enough change to expose new homes and new properties to noise exposure levels that would require sound insulation treatment. As I also mentioned earlier, the residential acoustical treatment program was completed, and there currently aren't any homes that would qualify for another program. Therefore, there won't be any windows replacements or other types of acoustical treatments moving forward, or any other compensation with respect to the noise exposure around the airport. And just to explain why is that the levels don't meet the federal requirement to receive funding to support those types of programs. So until and such time that those contours encompass new areas or noise exposure increases enough so that there are homes that the FAA recognizes as being impacted, unfortunately, there wouldn't be any new residential acoustical treatment program or any type of compensation related to these programs.
Thank you. Neil, could you share again quickly how people can provide official comments and a reminder on how to submit their questions as well?
Sure. So yes, we highly encourage everybody to submit their comments or thoughts on the current project. Importantly, if you submit them in writing, they become part of the official project record, and they will be included and addressed in the NEM update report. So there's effectively two ways you can do this. First, you can send an email to Airport Noise Hotline at sanantonio.gov, and that needs to be submitted by 5 p.m. on March 19th. The other way you can submit your written comments is through regular mail, and that has to be postmarked by March 19th. And the mailing address is in front of you, but it's San Antonio International Airport, 457 Sandow Road, Building 1039, Attention Environmental Stewardship, San Antonio, Texas 78216. So just reiterate, if you submitted a question via Zoom, that's not considered part of the official record. So please submit your comments or questions or thoughts in a written format, either email or regular mail.
Thank you. Our next question is for Chris. At what altitude for aircraft passing over was the noise measured on the approach for runway 13 right?
Thanks for the question, Autumn. And I would say that every aircraft arrives at different altitudes, and that's for a number of reasons. One is just for performance reasons, because each aircraft flies a little bit differently. There is a standard glide slope that is typically followed, and for many places around the country, it is 3 degrees as a glide slope, as we call it. And the purpose of the glide slope is to bring aircraft to the ground in a controlled manner so that aircraft are not going too fast or too slow or descending at a rate that's too steep to safely land. So for every aircraft operation that happens at the airport, on approach, we could see a variety of altitudes. They'll all be within a certain range, that 3-degree safe range that is used in many places across the country, but there could be variations higher or lower. And what we do is, in the development of our noise exposure maps, we review actual operating data for aircraft operations around the airport and get a sense of those altitude profiles. And so we can represent those in modeling to produce the most accurate noise exposure contours that we can. So fundamentally, we'll see for every location variations in altitude depending on factors such that I mentioned, like aircraft types. There are other factors that affect altitudes like weather conditions, but fundamentally, we try to represent those in our modeling process. There's no one altitude. There is a range, but it is also a constrained range.
Chris, I was wondering if you could talk a little bit about the model itself and how it calculates noise relative to different points along the approach and departure profiles. That might be helpful. This is talking about measurement at a single point, but we are actually, because we're using a model, it's using the data that's in the model. And maybe you can talk a little bit about how that data is developed and used.
Sure. So one of the presentation facts that was highlighted a number of times was the fact that we do use models rather than noise measurements at specific points, because the purpose of the model is to generate noise at a wide area around all corners of the airport at many different virtual points in the model. Ultimately, that gives us, in some sense, thousands of noise predictions that we can use not only to look at the noise from the current condition of operations, but also the potential noise in the future. And of course, looking at the future operation is not something that you can do with noise measurements. So in the process of developing these thousands of noise values at points around the airport, the model, Aviation Environmental Design Tool, actually flies the aircraft in the model and generates the noise from it. And the way that it does that is the model contains FAA provided data on aircraft type and engine type. And there are actually about 4,000 different combinations of aircraft and engine type in the model. And in reviewing our data and also coordinating with the FAA, we're able to take those aircraft types and represent them in the model so that they're most representative of the operation. So AEDT actually flies the aircraft in the model. There is not only an aircraft and engine type that's specified, but we also specify what we'll often refer to as a vertical profile, or the way in which an aircraft's altitude changes over time. And those pieces of information essentially represent where the aircraft flies. There are then other algorithms, industry standard algorithms, that model the noise from that aircraft and how it travels to all of those noise modeling points on the ground. Thank you.
Thank you. The next question is for Steve Alverson. What is the difference in noise from a wide body versus smaller aircraft?
So that's certainly a difficult question to answer because it depends on a number of different factors. Where on the ground are you experiencing or measuring that noise? What type of activity is the aircraft flying? Is it arriving or is it departing? And so how is the aircraft configured? Where is that aircraft going? One of our slides indicated stage lengths. If an aircraft is flying to a further distance and carrying more fuel and more people, it climbs a little bit more slowly than an aircraft that's flying to a shorter distance. So it's virtually impossible to answer that question specifically without those types of details. But in general, as you get larger in aircraft size, noise levels tend to go up a bit, but not always. And the reason that I say that is that as the FAA's regulations for aircraft noise have become more stringent over time, even the most modern and large aircraft that have been developed have become quieter and quieter. So there are some instances where there's some fairly large aircraft that are quieter than some of the smaller aircraft. One example that I can provide is for the MD-80 aircraft. It has been generally recognized by the community as one of the most noisy aircraft that operate not only, or did operate at San Antonio and other airports throughout the country. And it's really two factors there. On departure, it's extremely noisy due to the types of engines and the way the aircraft performs. But on the arrival, it's quite quieter than some of the smaller regional jets because of the location on of the engines on the aircraft and how that aircraft is configured when it lands. So there's a lot of variables that are involved there. The good news is on the MD-80 that it, along with a number of other aircraft, have been shelved, put to permanent rest during the COVID pandemic, and it's not likely that we'll see those aircraft into the future. Thank you.
And the next question is also for you, Steve. Sound insulation is great, but if you want to be outside your house and use your pool or yard, what can you do to mitigate the noise?
Well, and that's the second part of the equation, is to work with the aircraft operators, work with the airlines to fly quietly as possible, to follow the noise abatement procedures at the airport. Again, Joshua and Steve in their role are an interface to the aircraft operators, and to make sure that they're doing the best that they possibly can, and to use the complaint system to identify particular instances when there are unusual or loud events. Ultimately, aircraft noise outside is, we can't abate that with any sort of treatment outside. So just working with the aircraft operators is about the best that we possibly can do to make sure that they fly as quietly as possible.
Thank you. We received a comment noting a resident was concerned that the noise contours didn't encompass Rilla Vista. And I'm not sure, Joshua, if you want to add anything, or if we need to show the contours.
Sure. And what we do is, as Chris and Steve have explained earlier, the different inputs that go into the Aviation Environmental Design Tool, or AEDT. It takes a look at the operations that occur on each of the runways over time and where we'll be going into the future. And that runway 422, often has conflicts with area Air Force bases, be it Kelly, Randolph, and we look at basing the operations on an average, not individual events. There are a lot of flights that go through the area. There's a lot of noise that occurs in the Rilla Vista neighborhood, but when we do the calculations, the contours don't move into the neighborhood. And so because of that, the properties are not eligible.
Josh, I would just acknowledge that noise does not end at the contour boundary.
That's right.
We know noise extends beyond. Many of you wouldn't be on this call tonight if it wasn't for that. So unfortunately, in many cases, based on that prescribed process, this is where we are relative to those areas of greater significance and the contours that result.
Thank you both. Our next question is for Steve Alverson. Is there any plan to require quieter aircraft and engines, presumably by the federal government?
Short answer is not immediately. However, it's important for all of the folks who are on the phone to know that the Federal Aviation Administration, or FAA, is responsible for certifying aircraft and certifying aircraft noise levels, so that every aircraft that's currently flying meets those federal standards for aircraft noise. Over time, the FAA works with international agencies such as the International Civil Aviation Organization, or ICAO, and their Committee on Aircraft Environmental Programs, or CAPE. And they work hand in hand to make sure that every 5 to 10 years or so, new standards are set, and those aircraft new standards become quieter and quieter. Also, the FAA has previously phased out, as a part of the Aircraft Noise and Capacity Act, or ANCA, in 1990, all of the older Stage 1 and Stage 2 aircraft that were flying at that time prior to 2000. And so leading up to 2000, there were a lot of noisy aircraft that were flying in the fleet: 727-200s, 737-200s, DC-9s, F-28s, and those aircraft essentially went away. Then the new standard from that point moving forward were what is known as Stage 3 aircraft. It was the next group of quieter aircraft. And then there was a new standard that was set that made the newly manufactured aircraft have to meet the Stage 4 noise standard. Again, another level of quieter going down. And all currently newly manufactured aircraft must meet Stage 5 noise standard. So when Boeing completes an aircraft, or Airbus completes an aircraft, it must demonstrate through flight tests that it meets those most stringent noise standards. So aircraft are becoming quieter. As a result, the noise exposure on a per aircraft basis is less, but certainly we know that as operations increase, that could be annoying to people. Having more planes or quieter planes over time is not necessarily palatable to the community. So, but it's work that's ongoing, and there's an effort always to make aircraft quieter as time moves on. And that is the responsibility of the Federal Aviation Administration.
Did you want to add something, Josh?
Not to this particular answer, but to the one just prior to that, with coverage for the Rilla Vista neighborhood. What I detail that I want to follow up and add to that is that a lot of times the direction of air traffic in the San Antonio area is under the control of the air traffic controllers. And a lot of times, especially today, when we have cool fronts, there's a lot of arrivals that occur on runway 4, and when so the frequency of utilization of that runway is often higher during the winter months with the cool fronts and winds coming from the north, and there often are not a lot of departures as a result of that. So what we take a look at is, runways availability, wind direction, and input from air traffic controllers to determine which direction the planes arrive and depart at the airport. Okay.
Thank you for clarifying. The next question is for Mike. Is speech interference and sleep disturbance part of a Part 150 study?
Well, the speech interference and sleep disturbance do factor into annoyance, but they're not specifically evaluated as part of the study. We're primarily evaluating compatible land use based on the criteria set in Part 150, which identifies various land use types and thresholds of compatibility. And that's what we're essentially evaluating.
Thank you. And the next question is for Steve Alverson. Are the parameters for noise abatement or sound insulation going to be widened? The current parameters exclude many houses that are nearing 20 years old, and window and noise mitigation was not considered when they were built.
Thank you for passing on that question, Autumn. So the Federal Aviation Administration sets the sound insulation parameters that airport operators like the city of San Antonio needs to follow. And the first parameter is, are there homes within the 65 DNL contour? When there are, then other parameters come into play. One of those is, do those homes reduce noise exposure levels to 45 or below 45 decibels? If they do, then those homes aren't eligible to be sound insulated. Essentially, they're providing the noise reduction that the FAA would expect to get out of an acoustical treatment program. The question, or the person who asked the questions, indicating homes that would be nearing 20 years old. Homes built within that time frame typically are built to higher standards, generally for thermal purposes, which also help from an acoustic purposes. Windows tend to be better, joints tend to be tighter, and those homes tend to perform better acoustically than homes that are much older than that. The second criteria too, which is relevant to the 20-year time frame, is that the FAA does not include homes that were built after October of 1998 in the program. So that clearly would put homes that are built after that time, or just roughly more than 22 years old, out of the program eligibility. So again, FAA sets the standards. There's, as far as we know at this point, there's no plans on FAA changing those standards moving forward, and they're all based essentially on the acoustics. If a home performs well currently and reduces the noise levels interior to levels that are acceptable under FAA criteria, then those homes don't qualify for additional sound insulation.
Thank you. Our next question is for Mike. Is it possible to stop using a runway, for example, runway 422?
No, I mean, the FAA uses the tools they have available to address operational considerations, such as weather conditions and how they evolve, as Josh indicated. And, the airport is not able to restrict use of one of those runways. There may be temporary closures or something to that effect for the purposes of runway maintenance. But the airport is not allowed to restrict operation of the airport in any way. And Josh, I see you want to add to that.
Yes, and excellent. What I wanted to touch on is that as part of the noise compatibility program with the latest Part 150 update from 2014 and 15, there were a number of suggestions for departure corridors or preferential runway utilization, and those are suggested abatement measures to be included in the compatibility program. But during the review and approval process of the FAA, those are disapproved abatement procedures because of the ability to maintain efficiency and capacity for utilizing the available runways. So there's not an opportunity to move aircraft over one neighborhood over another, or to use a specific corridor or a specific direction in this case. Anyone can have aircraft overhead their neighborhood at any time. We operate 24 hours a day. And the direction and utilization of the runways is under direct guidance of the FAA and the pilots running those aircraft.
Thank you. The next question's also for Joshua. Will the airport be coordinating with the city's planning department to update the San Antonio tomorrow's future land use map with the new noise patterns?
We, as part of this project, also include coordination with the development department for the city of San Antonio to get a copy of this report, to be aware of these updates that are in play. And as development in the airport hazard overlay area is proposed, or the AHUD, we get notifications and we evaluate those on a case-by-case basis. So we do keep close coordination with those departments to let them know where noise is developed as part of these part of this noise exposure map update.
Thank you. Our next question is for Chris. Can you provide the number of flights increasing on a daily basis? How many flights are departing from San Antonio now per day, and what the increase is expected in the future year?
Thanks for relaying that question. So I do have a data table in front of me, and I thank our support team for providing this information. In the year 2019, we had a total of 224 flights. This is daily flights across all runway ends, and this is daytime and nighttime. I'm sorry, the year 2021. And in the year 2026, per the FAA forecast, FAA approved forecast that we use for this study, we are expecting a total of 250 daily departures. And again, that's across daytime and nighttime. And the breakdown of that is 212 in daytime and 38 at night. And again, these are departures across all runway ends for the forecasted year 2026 for future conditions here, as we say in the Part 150 world.
Thank you. Our next question is for Neil. Is it possible for you to share the contour map? We had a participant join late, so they haven't been able to, they missed the presentation and didn't see it. But adding on to that, I will ask Steve Alverson to clarify about the potential for funding a sound insulation program, window replacements.
Sure. Did you want me to go first on?
You can do that while Neil is working on graphics.
Okay, good. So welcome to the meeting that our person who just joined. We showed earlier, and Neil will bring them up, the noise exposure maps for 2021 and for 2026 for the airport. And they indicate that there are no new homes within those contours that would be eligible for sound insulation or a residential acoustic treatment program. So therefore, the city of San Antonio would not be pursuing additional funding because there would be no eligibility for it. And at least at the moment, there wouldn't be any residential acoustic treatment program moving forward based on the size of the contours. And I see Neil is bringing those contours up on the map now.
Yep. So yes, I'll just go back here 2 slides. Here are the 2021 existing condition contours, and here are the 2026. Now I know this is difficult, probably difficult to see on your screen. So one of the things that you can do is go to the Airports Noise Office website. This presentation is available for download there if you want. Also, much higher resolution and much larger contour maps are available in the NEM update report, which is also available for download at the website. I would suggest you check Appendix I, that's where the big maps are contained, if you want to see the really detailed high resolution versions. And then we've got a number of printed copies of the presentation at the report at various public libraries across the city. And Josh, I don't know if you wanted to mention those locations real quick. Mute.
Well, Josh, just bring those up. I'll just quickly mention, as Mike Arnold did earlier, it's important to remind everyone as we look at these noise contours that we recognize that noise just doesn't stop at the 65 dB line. It extends well beyond that, and people throughout the San Antonio area hear aircraft taking off and landing. The importance of the 65 dB contour line is the definition of non-compatible land use in the area in which, if there were newly impacted homes, the city would be able to apply for federal funding. As I mentioned, that's not the case. The city won't be able to do that based on the size and shape of these maps, but we do want to acknowledge that clearly there are many people on the phone who feel impacted but live outside of these contours.
And while we have this up, and I think maybe Steve, you can elaborate on it, One commenter asked about extending the contour lines beyond McAllister Park to encompass homes that are south of the park and near the airport.
So when there is a residential acoustic treatment program, there and there was in the past at San Antonio, there's a process to look at potentially rounding contours off with the to the nearest block. And so that has happened, that does happen. In this case, as I mentioned, there won't be any additional sound insulation work based on where the contours are located, and therefore there won't be any rounding of these contours. A correlate question to that is people often ask, well, you know, I'm here, my neighbor got sound insulation across the street, why wasn't I treated? And the answer is the line has to stop somewhere, the contours need to stop somewhere, and unfortunately, at some point when they stop, there's folks on one side of the street that get treated and folks on the other who don't. Again, recognizing that noise doesn't just stop at the contour line, but those are the federal criteria that the city of San Antonio needs to follow in order to be able to apply for and receive federal funding for these types of programs.
Thank you. The next question is for Mike. Are noise levels the same for departure and arrival flights?
I know they can vary quite a bit. Aircraft are under a much higher thrust setting, typically on departure than they are on arrival. So depending on where you are, the type of noise that you experience may be very different depending on the type of activity that occurs. And I was hoping, Steve, you talked about the noise and the evolution of aircraft as time has gone on. Can you talk a little bit about the airframe considerations versus the engine considerations when it comes to noise and how that is changing as well?
Sure, happy to do that, Mike. I mentioned the FAA and their ever increasingly stringent noise standards, as well as the International Civil Aviation Organization. And where the aircraft manufacturers have gotten the most benefit or noise reduction has been in the aircraft engines. And that's been a lot of focus over the years. For those of you who see aircraft landing and taking off and have been around the airport for a long time, you've noticed that aircraft engines, and I'm talking specifically about turbofan engines, have gone from being fairly narrow engines to being much wider, much larger openings, which we refer to as high bypass engines. As those engines have gotten quieter, it's made what we refer to as the airframe noise or aerodynamic noise more prevalent. So what was hidden before, and particularly on arrival, was wind whistling through landing gears over the slats and flaps of the aircraft has now become a component of the noise exposure that people experience. Good news is aircraft manufacturers are very aware of this. A lot of research has been done on this, and aircraft manufacturers are working to eliminate those additional noise levels in calming or quieting, if you will, that aerodynamic noise related to those various items coming off the aircraft. It also has a secondary benefit for the aircraft operators in that if you make the aircraft a little bit more sleek, a little bit more smooth, it performs better, it saves fuel, operates more efficiently, and reduces emissions. So it's a win-win situation. But we certainly have heard in our work around the country that people have noticed some of that aerodynamic noise more than in previous years, simply because the engines have become so quiet. But it's being worked on.
And that's a factor that is also a distinction between arrivals and departure noise as well, different airframe characteristics and noise related to the airframes.
Absolutely.
I will note that when we talk about the noise levels for the departure and arriving flights, when you look at the noise exposure contours, those do reflect equal levels of exposure. And so that's the combination of all those arrivals and departures ultimately. But depending on where you are, how that contribution and how that shape results may be very different. And there was a graphic in the presentation that showed wide variation in the number of aircraft that may make up what the 65 DNL contour is. And again, departure and arrival flights are the difference between those are a key factor in that.
Thank you both. Next question is for Tracy. Can you elaborate on the future development of airport facilities and the master plan?
Certainly, Autumn. The airport is currently undergoing a master plan study, and the master plan looks at the airport facilities for the next 20 years based upon what the projected demand is going to be, and that includes both aircraft operations, the fleet mix, as well as the number of passengers that will be going through the airport or projected to go through the airport in the next 20 years.
Thank you. Our next question is for Steve Alberson. The noise has significantly increased around the Churchill High School area on Blanco West Ave. Will it be possible to change the times of departures or arrivals so we're not woken up so early and kept up late at night? And commented about the age of their house from the 80s and not built to the same noise standards.
So the city of San Antonio, as the airport operator, has no role or ability to determine when aircraft arrive and depart. Using the airlines, for example, or the air cargo carriers, they set their schedules at the time that they need to, in the case of passenger airlines, to meet passenger demand, and in terms of the cargo carriers, to get the cargo to where it needs to be at the time that it needs to be there. Essentially, federal law prohibits the airport from being involved in that process. And as we mentioned earlier, the airport has accepted federal funding to do improvements at the airport. And as a result of that federal funding, the city is obligated to keep the aircraft or the airport available basically 24 hours a day, 7 days a week to those operations that the airlines and other aircraft operators want to schedule. So unfortunately, the city really doesn't have the ability to do that. I'll just add one final dovetail to that. And previously, years ago, airports had more of a greater role to restrict operations, particularly at night. And then in 1990, the Aircraft Noise and Capacity Act, or ANCA, was put into place by Congress. And what it did was, in exchange for the airlines phasing out their noisier aircraft, it basically restricted airport operators like the city of San Antonio from being able to restrict aircraft operations at their airport. Since 1990, there's only been one airport that's been able to put restrictions in place. That's Naples, Florida, a general aviation airport. And there have been many other airports, a couple dozen airports that have tried to put those in place, and all of them have lost. So it would be extremely difficult, if not impossible, for the city of San Antonio, as the operator of the airport, to restrict operations of the airport based on time.
Thank you. Our next question is for Mike. A commenter had not heard about the 1997 cutoff before for eligibility. Can you please explain the source of that?
Yeah, the FAA, Steve referenced the Airport Noise and Capacity Act of 1990, but there's a variety of different things that the FAA has implemented over the years. And one of the clarifying elements in their noise policy in the 1997-98 timeframe was an indication that if new homes were built in areas that had been previously identified as non-compatible, the federal government would no longer participate, and those homes were no longer eligible for sound insulation treatment, essentially indicating that this was a known new construction of a non-compatible use within areas that had been previously identified as non-compatible. And so depending on when noise contours had been updated and the areas around the airport had been shown within the 65 DNL contour, it had the potential to affect eligibility of homes. And as a result, in some cases, such as San Antonio, homes that were built after 1998 were not eligible for consideration as part of the residential sun insulation program.
Thank you. And I previously misspoke. I meant to say 1998 earlier. Our next question is for Chris. Can you explain in detail the noise model inputs?
Sure, thanks for relaying the question, Autumn. And I will reference the presentation in general, but also I recognize that some of our participants joined us after the presentation concluded. Essentially, there are a couple categories of inputs that are critical for a noise modeling process. And for all of those inputs, we use official data or data that's been recorded historically, such as radar data. And the way it breaks down in those categories is we look at the aircraft and engine types. We look at the flight paths that the aircraft use and will use, and particularly that's based on historical flight tracks that we often get from radar data. We look at the aircraft weights because the weights actually, we look at the destinations and origins, which is a proxy for the aircraft weight, because oftentimes aircraft that are flying for farther distances take on more fuel and therefore weigh more and need more power to climb out, and that affects the noise levels. Finally, we look at runway use, which is often directly related to the airport layout and the weather conditions. The runway use and flight tracks together affect essentially the directions of aircraft that are set in the noise model. And going back to the weather, aircraft are heavily impacted in terms of their performance by weather. Aircraft, we nearly always want aircraft to take off and land into the wind. So wind direction is a major factor in the runways that are used at the airport. And things like temperature and humidity and pressure also affect how aircraft fly in terms of their climb out performance in particular. And weather also affects how noise propagates from the aircraft to the ground. As mentioned previously, we also include terrain in our model because terrain affects the distance between aircraft and the homes on the ground. And we want to consider that in the modeling process as well. So we've included all those factors in the modeling. Many of those are based on official data sets. So we get the airframe and engine data directly from the FAA. It's built into the model. That model also has built-in climb out and arrival vertical profiles or altitude profiles provided by the FAA. We look at actual weather in terms of the average historical measured weather in the airport, and we use that in the model. And of course, the terrain data comes from the US government as well.
Chris, if I could have you expand, there was a question the other night that might be of interest to folks on the phone, and it related to buildings and how buildings are considered in the model. If you could talk about that a little bit.
Sure, I'll talk about that particularly in terms of what we observed in the previous workshop regarding how buildings, particularly large buildings, affect the noise. And so we acknowledge that when sound comes to the ground, it is affected by objects in the vicinity. So we're talking about sound bouncing off of things like windows and other hard surfaces. So we, in the acoustics world, typically speak of sound reflection, sound refraction, and sound shielding, or in other words, buildings that may shield a sound source by basically being in the way of the aircraft and the person hearing the noise. So at this point, the FAA does not have an approved method for calculating how buildings on the ground affect and shield and amplify and bounce noise from aircraft. That's been an active area of research, and of course it's been known for a long time that noise sources and the way we hear noise is affected by those types of elements, the things on the ground that are basically in the way of the sound waves. It is an active area of research that FAA is working on, not only with industry in terms of aircraft manufacturers, but also with federal agencies such as NASA that look at some of this advanced data and work on algorithms. One of the things that is unique to the aircraft world versus, shall we say, trains and cars and other ground sources that move between buildings is that much of the noise that we experience from aircraft is aircraft overflights. And the noise from those is less impacted by large buildings and other things that typically shield ground sources, but don't shield aircraft sources in the same way. So, and once again, that is an active area of research. The approved model, which is the Aviation Environmental Design Tool, does not include those algorithms at this time, but the FAA does have a noise research roadmap as well as a model development roadmap that may potentially include that type of algorithm in the future.
Thank you. Our next question is for Steve. I noticed the military operate and they can often be very loud. Are they exempt from the noise requirements?
Thank you for the question, Autumn. Yes, military aircraft are not required due to their mission of providing national security, of meeting the civil aircraft noise certification requirements that I mentioned earlier. They have a different mission in mind. They have different performance requirements in mind. There are high performance jets. There are air cargo aircraft that operate, and no, they don't need to meet the same civil requirements. It is important to note, along the lines that we mentioned earlier, in terms of the city making the airport available to all operators, the military is included in that. And so when the military feels the need to come to San Antonio International Airport and to train for proficiency, you will see aircraft come over and train, doing touch and go activity at the airport. They also will come over and refuel at the airport, as well as they're making cross-country flights. And it might seem unusual to the community as to why does a military aircraft have to use a civilian airport when there are military airports nearby. And the answer is the pilots, for their proficiency, need to be able to fly into all types of airports throughout the world. So it's fairly common to see military aircraft training at civilian airports, particularly when there are military air bases nearby, as is the case at San Antonio International Airport.
Thank you. Our next question is for Mike. How did COVID impact aircraft operations?
Well, COVID had a significant impact on air travel nationally, beginning in about the March timeframe and especially into April. Commercial service airports such as San Antonio are still experiencing the effects of COVID, and the large decrease in passenger travel resulted in the airlines scaling their operations, reducing their operations to reflect the reduced demand for that air travel. In 2020, San Antonio had about 69% of the activity level that they experienced in 2019. This is one of the reasons why we use 2019 for the 2021 year, the modeling year, because it was the last real year of normal type activity at the airport. We are seeing that that activity is beginning to rebound slowly, though, and it's still very much up in the air how long that's going to take. For the purposes of this noise modeling effort, we assumed that there would be about a 2-year shift in activity. So I think, as Neil indicated earlier, 2024 is what was originally forecast for 2024. It is now probably not going to be reached until at least 2026, and that's what we use the forecast for that future year. Another consideration, Steve talked a lot about the evolution of the airline fleet and how things have changed over time, and the fact that many of the noisier aircraft over time have been retired from the fleet. Well, COVID has actually accelerated the retirement of some of those older, noisier aircraft. So we look at that transition, that accelerated transition of those older, noisier aircraft. That has occurred more quickly than originally anticipated, and that is reflected in the 2026 contours as well.
Thank you. The next question is for Steve. What is included in an NEM update?
So an NEM update clearly includes the two maps that we showed earlier, the 2021 existing condition map and the 2026 future conditions noise exposure maps. Those are the cornerstone of the noise exposure map update. In addition to that, we prepare a noise exposure map report, which provides all of the information that went into updating those, creating those contours. So the aircraft types that we're operating or expected to operate, the runway use, the flight tracks, the flight track use, the temperature assumptions, humidity, all those types of things go into that report, as well as the land use, both the existing land use and, as was discussed earlier, the future land use surrounding the airport, so we can see what those development patterns are. The report contains tables about the potential impacts with different residential and land uses, hospitals, schools, as well as other types of compatible land uses within those contours. And importantly, it includes documentation of this process, the public workshop process, and receiving and responding to the comments, the written comments that you provide at the address that was provided several times during this meeting, and will be provided again before we wrap up. It's important to get the input from the public and other key stakeholders, that if there's something you see in the report that we prepared that's of concern, that you raise that concern. We will then attempt to address that, and that gets all wrapped up and submitted to the Federal Aviation Administration for their review. Ultimately, the hope is that the Federal Aviation accepts these noise exposure maps documents, and then those become the official noise exposure maps for San Antonio International Airport, until at some point in the future, another noise exposure map update is prepared. That update would be completely within the hands of the city at a time that they feel they would need to do that, or unless there was a significant change in the operations at the airport that might compel them to take a look at the noise exposure at that time.
Thank you. Next question is for Joshua. Is the city developing a plan to notify homeowners that their home is located within the DNL 65 contour? They commented that it should be a disclosure requirement, just like if a buyer was in a floodplain.
Thank you for the question. Taking a look at the history of the residential acoustic treatment program, in the instances where there were properties that were identified within the 65 decibel day-night average or DNL contour, those homes were contacted through the program managers that manage the residential acoustic treatment program, either through mailers or identification that, by contacting the homeowners. And going forward, to take a look at real estate disclosures, there's not a requirement in place where that's been approved by the Texas Real Estate Commission or TREC or local real estate agencies to include that notification in real estate transactions. When a property is treated through the residential acoustic treatment program, it is often the case that there is a avigation easement included that identifies that the property was treated, but it is basically the real estate agent's duty to identify that if the avigation easement is in place, that the property was treated, and reviewing these planning documents to identify whether the property is inside the 65 decibel contour or outside.
And Josh, I would add that COVID has really complicated that process with the way that home sales have been occurring with entities like Zillow. We're seeing more sight unseen home purchases and more purchases where it's more challenging for the buyer to fully become informed and to actually visit the site because of travel restrictions or otherwise related to COVID. Something that we've been working with realtor boards in various parts of the country to try to help get the word out as much as we can through those realtor boards and try to instill it in the best practices. But implementing any type of a disclosure at a state level has been incredibly difficult. I think only 1 or 2 states in the country have been successful in implementing something like that.
And as part of this effort, they've, the realtor associations have been contacted to make them aware that this update is in place and to invite them to participate. That's part of the reason that this plan is available publicly, so that individuals can review the map as well as real estate agents to be aware of not only what future conditions will be, but what current conditions are. Thank you.
And one thing I might add as well is that after the FAA accepts these noise exposure maps, the city will publish notice of the availability of these maps and their preparation in local newspapers of general circulation 3 times, so that, again, casting as wide a net as possible to make people aware that these maps are out there and certainly viewable at the airport and online if they'd like to see them.
Thank you all. Our next question is for Tracy. Don't we need projections for the noise contours after the airport expansion is done, since it won't be complete by 2026?
Thanks for the question, Autumn. As part of the master plan, we are developing a noise contour for the 2040 airfield and fleet mix projections and aircraft operations, similar to what was done for 2026. However, that particular noise contour will have will not have any implications on the existing or finished residential acoustical treatment program that the airport is doing.
Thank you. Our next question is for Steve. There are low flying helicopters right over our homes. Can flights be directed away from us?
Thanks for passing along the question, Autumn. So, assuming these aircraft or helicopters are operating fairly close to San Antonio International Airport, the likelihood is that they're under the control of the Federal Aviation Administration air traffic controllers, providing guidance and separation from the other aircraft. It's the FAA who's responsible for the safe and efficient operation of those aircraft and protecting not only the people who are on those aircraft, but also all those of us on the ground below them. And so, in most cases, those aircraft are being watched over and under control. But if you see something unusual happening, certainly you have the ability to let the airport noise office staff know about that, particularly if it's going on for a long period of time or over a period of days, to let them know that that's occurring using the complaint system. Or if it seems like it's something that's particularly concerning, there is a Flight Standards Division office of the FAA that is interested in those types of activities. However, in most cases, in an area around an airport like San Antonio International Airport, those helicopters are likely under the FAA's control. And unfortunately, no, there's not an opportunity for the city to move those helicopters, because it's the sole jurisdiction for the FAA to manage the national airspace system.
Thank you. Our next question is for Mike. Your map showed quite a spread of flight patterns for runway 13 right. Why is the noise contour line so focused in line with the runway and not more spread out based on flight patterns?
It's a really good question. And it has a lot to do with how we develop those flight tracks. We're looking at an annual average day, which means we're analyzing all of the aircraft flight tracks that occur throughout the course of a year. And during the course of a year, you have various weather patterns and operational conditions that have placed aircraft in various places around the airport. Many of those are fairly infrequent, and some of those are much more frequent. When you look at runway 13 right, runway 13 right is the primary arrival runway for the airport. And as a result, the aircraft arriving to that runway, when I think Chris mentioned earlier, or Steve, when aircraft are on an arrival or an approach, they're on a stabilized approach straight in, much further from the airport. They need to maintain that glide path that Chris was talking about, and maintain the airspeed and all the proper factors to be able to make that safe landing. Because they are on such a very fixed route, it means that noise signature is very concentrated for those arrivals. And so when you see that kind of peak, or that tip, that long narrow tip with the 65 DNL contour, it's really reflecting the noise generated by that primary arrival path into the airport.
Thank you. The next question is for Chris. Is aircraft thrust reverser noise on arrivals included in the model?
Thanks for relaying that, Autumn. And the very straightforward answer is yes, it is included. And just to elaborate on that a little bit, the AEDT model actually has an assumption built in for aircraft thrust reverser usage based on a review of data that was done at the time of development of the noise algorithms that are now inside the model. And of course, not all aircraft have thrust reversers. We're primarily talking about jet aircraft that use these types of devices to slow down rapidly on landing because of their high approach speed. The noise associated with that is actually a part of the modeling process. And so there's an automatic assumption that's applied that basically references common thrust reverser usage practice that's put into the model, and therefore we do get the thrust reverser noise calculated, and those are incorporated into the noise contours.
Thank you. And I believe we're at our last question of the evening. This is for Steve. What is the purpose of noise monitoring if you don't use the data in the modeling?
Thank you for passing on that question, Autumn. And the purpose for noise monitoring is really for several reasons. One, it's for the airport noise office staff to use to monitor trends at the airport, to see what's happening out at the airport on a daily and ongoing basis, to use those monitors and the flight tracking system to correlate to aircraft events, and to have that data at hand to help supply it for studies like this, where we pull, for example, the flight tracks into our noise model and model those as they were flown at the airport. So it's important to note that there are 12 monitors in San Antonio's noise monitoring system. And what the system tells you is what the noise exposure is at those 12 noise monitoring sites. And while it is designed to help focus on aircraft noise, it also picks up noise from all other noise sources. So street traffic, other types of activity in the neighborhood, leaf blowers, that type of stuff. So in essence, it's not a clean, if you will, aircraft noise source. And as a result, the Federal Aviation Administration does not allow those measured noise levels to be used in the modeling process. In the Aviation Environmental Design Tool, which Chris alluded to earlier, or the AEDT, it has a substantial database of aircraft measured noise levels that were taken as a part of the noise certification process and through other processes. And it's a known database. So we're able to use that model to generate the noise exposure around the airport. And rather than looking at noise exposure at just 12 locations, it gives us a chance to look at noise exposure over a very broad area around the airport, essentially creating those noise contours that we develop. So in part, it's because the information within the monitors are not directly usable within the noise model, and federal regulations prohibit us from doing that, but also the model gives us an advantage of looking at noise exposure for a broad area. Finally, to wrap up this question, what modeling allows us to do is look at noise exposure in the future. So as we've done here for this noise exposure map, we're looking at 2026. Obviously, we can't measure in 2026 because it hasn't happened yet. And as Tracy mentioned earlier, there'll be efforts to look at noise exposure beyond that as a part of the master plan process. So that's the real benefit of noise modeling versus noise measurements.
Thank you, Steve. And thank you for everyone that submitted questions tonight. We really appreciate you joining us for today's virtual workshop. We hope that you found the information helpful and informative. As a reminder, the public comment period is open until March 19th. Please follow the instructions on screen and also provided on the airport's noise office website and in the newspaper advertisement to submit your comments on the NEM update. Comments must be submitted or postmarked by 5 p.m. on March 19th. The email address is airportnoisehotline@sanantonio.gov, and the mailing address is San Antonio International Airport, 457 Sandow Road, Building 1039, Attention Environmental Stewardship, San Antonio, Texas, 78216. Today's meeting materials will be posted on the airport's noise office website, which is fly-business/about-SAS/environmental-stewardship. Thank you again, and we appreciate your participation.